Welcome to the deep dive. Imagine writing a check for $10 million just to change a single solitary field on a customer intake form.
It sounds completely absurd.
Right. I mean, it's nuts. But if you work in a massive enterprise, you're probably nodding along right now because that is just a daily reality.
Unfortunately, yeah, it really is.
So today, our mission is to uncover the true hidden cost of aging enterprise technology. We are drawing from a highly insightful article by Codora titled The Hidden Integration Tax of Legacy Systems and How It Compounds Over Time.
It's a fascinating read.
It really is. So if you have ever sat in one of those brutal cross-functional meetings and thought, why on earth is this simple software update taking 6 months and burning through triple the budget? Well, we are going to answer that for you today.
Exactly. And spoiler alert, it is almost never the core application itself that drains the budget.
Wait, really? It's not the core.
No, almost never. It's the tangled web of connections around it.
Okay, let's unpack this. Because the source material really challenges a basic assumption we all make, I think.
Oh, for sure.
When we hear the phrase legacy system, we picture this massive, dusty mainframe from the 1980s that just costs a fortune in maintenance contracts.
Right, like an old dinosaur.
Yeah. We assume the IT budget is being vaporized just to keep that old software breathing. But Codora completely flips that script. They argue the fastest growing cost center is rarely the core application.
Because the core system is usually just sitting there, highly stable, doing exactly what some engineer programmed it to do 3 decades ago.
Just chugging along.
Exactly. Processes the ledger, it stores the customer record. The actual drag on the business is the invisible tissue connecting that core to everything else.
They call it the integration tax, and I want to get into the mechanics of this. How exactly does a company accumulate this tax?
Well, to understand the mechanics, you really have to look at how a company evolves. Legacy systems are never truly isolated.
Right.
Over decades, they inevitably become these massive, dense, gravitational centers for all of the data and business logic of a company. Let's use a concrete scenario.
Okay, lay it on me.
Imagine a major bank running a core ledger system built in, say, the late 90s. The bank wants to grow, so they launch a mobile app.
Makes sense.
But that requires a custom connection to the core. Then they acquire a smaller regional bank. That's another massive data pipeline.
Oh, man.
Then a new federal privacy regulation drops, requiring real-time reporting. That's another connection. The core system itself hasn't fundamentally changed, but the surface area around it has expanded exponentially.
And every single one of those new connections carries a toll. I mean, the text breaks this invisible tax down into a few distinct, really painful categories.
They do, yeah.
Let's look at that bank trying to add, say, Apple Pay integration. First, you have the raw engineering cost. You have developers physically building a custom pipe between a modern iOS environment and a 30-year-old database.
And that pipe is going to be incredibly fragile.
Exactly. But the coding is almost the easy part compared to the coordination cost.
Oh, coordination is where the budget truly evaporates.
How so?
Well, because integrations are inherently cross-boundary, you can't just have 2 developers in a room knock this out.
Right. It's never that simple.
To build that Apple Pay pipe, you need the legacy database team, the mobile front-end team, the cybersecurity risk assessment committee, the compliance officers,
Sounds like a nightmare.
and probably 3 external vendors all trying to align their schedules. You are spending thousands of man-hours just on alignment and governance before a single line of code goes to production.
Because everyone is terrified of the WIS cost. That's the phantom menace in all of this.
Oh, absolutely.
Let's say that massive committee finally approves the Apple Pay integration. They push the code live. And the moment they do, an entirely unrelated internal HR portal goes down.
Yep, happens all the time.
Why? Because 15 years ago, someone wired the HR portal to verify employee accounts using the exact same data endpoint that the new Apple Pay system is now overloading.
A change over here inexplicably breaks something way over there.
Which forces the final and arguably most devastating component of the tax, the opportunity cost.
Right. Your best engineers, your most expensive architects are suddenly pulled off designing the next generation of banking products.
Because they have to put out fires.
Exactly. They are stuck in a war room for a week trying to figure out why the HR portal crashed. You are spending your entire budget and all your creative energy just managing cascading outages.
You are completely stifling your own ability to innovate. And the wildest part is that this tax is completely invisible on a ledger.
That's the scariest part.
Nobody writes integration tax on a spreadsheet. It's smeared across dozens of different project budgets and incident response tickets.
It's totally decentralized.
To help visualize this, let's look at a historic downtown building.
Okay.
The building itself, the core legacy system, is perfectly fine. The foundation is solid rock. But the nightmare is trying to run modern plumbing, high-speed fiber optics, and new traffic lanes into it without breaking anything else in the surrounding city.
Oh, I like this.
You dig a hole for a new fiber optic cable, and oops, you just hit a high-pressure water main from 1920.
Right.
But the real problem isn't just that the pipe is old. The real problem is that the engineer who laid that water main retired 40 years ago, and the original blueprints burned in a fire.
You have no map.
Exactly.
Yeah.
You have no mass. So every time you dig, you are digging completely blind.
What's fascinating here is how perfectly that analogy captures the compounding nature of the problem, specifically the lost blueprints.
Yeah.
The text makes a crucial point. Integration effort grows non-linearly.
Non-linearly. Okay, explain that.
If you dig blind and add one new pipe to your historic building, it's hard. But when you go to add the 10th pipe, you aren't just navigating around the building anymore.
Oh, I see.
You are navigating around the 9 other undocumented pipes you and your predecessors already laid down.
That sounds impossible.
It is. Integration work overtakes core development as the dominant driver of delay because every new connection forces you to tiptoe around an ever-growing minefield of past decisions. It just accelerates.
Okay, I get that we need fast integrations to survive, but I don't understand how the actual rules of the business end up migrating. I always thought the core system was the brain.
It's supposed to be.
But the source talks about this concept of logic leaking. If the core system is the brain, how does the business logic end up leaking out into the connections? Like, why wouldn't smart companies just update the brain?
Well, think about the timeline of enterprise delivery. Let's go back to our banking example. The marketing department wants to run a special temporary holiday promotion.
Okay.
Users get a fee waiver if they transfer funds using the new mobile app. Now, the engineering team looks at the monolithic legacy core system. Updating the core ledger to handle this temporary fee waiver requires a massive recompilation.
Just for a temporary promo.
Right. It takes 6 months of regression testing and sign-off from the board. But marketing says, we launch in 3 weeks, or we lose the holiday quarter.
So the engineers are trapped.
The developers have no choice. They can't touch the core. So they write the fee waiver logic directly into the integration middleware.
Middleware.
Yeah, the customized connection sitting right between the app and the core.
Wow. So they just bypass the brain entirely.
Exactly.
The core system still thinks the standard fee applies, but the middleware intercepts the transaction, applies the discount, and alters the record before it hits the database.
Bingo.
So the actual business decisions are happening in the empty space between the systems.
And that is logic leaking. The core system no longer holds all the rules. The business logic has leaked out into the surrounding connections.
That's incredible.
But remember the lost blueprints from your analogy. 3 years later, the developers who built that quick holiday workaround have left the company for a startup.
Oh, of course they have.
The documentation decayed, or maybe it was never even written because they were pulling all-nighters to hit the deadline.
So the enterprise just forgets how its own promotions work.
It forgets how its own systems function. This decentralizes decision-making in a highly dangerous way.
I can imagine.
As Kodor points out, every new system update now requires an exhaustive process of rediscovery.
Rediscover.
Because no one knows where the logic lives anymore. Teams have to constantly trace data flows, validate assumptions, and literally guess how things work by running test transactions and watching what happens.
That sounds so tedious.
It is. The integration debt inherits the fragility of every single integration that came before it.
Okay, wait a second. I have to push back here.
Go for it.
Because anyone who follows the tech world knows that there is an industry standard answer to this exact problem, and it's OPI.
Yes. APIs.
I mean, tech companies constantly pitch APIs as the ultimate magic bullet for connectivity. The whole pitch is that you don't need to understand the messy legacy code. You just wrap your old system in a clean API, and you instantly have modern, standardized communication.
Right.
Are you saying APIs actually make this situation worse?
This raises an important question, and it's perhaps the most common misconception in enterprise architecture today.
Really?
Yeah. APIs are fantastic tools. They are absolutely essential. But the text explicitly states They are not sufficient on their own to eliminate the integration tax.
Okay, why not?
The myth is that adding an API somehow magically organizes the underlying complexity. But an API only defines an interface. It does not define behavior.
Interface versus behavior. I want to dig into that distinction. If an API is a standardized interface, why isn't that enough?
Think of an interface as a menu at a restaurant.
Okay.
The menu tells you exactly what you can order: a burger, fries, and a shake. It standardizes the request. You don't have to walk into the kitchen and shout instructions at the chef.
Which is great.
That is exactly what an API does. But that menu tells you absolutely nothing about the behavior. What actually happens behind the swinging doors.
Oh, I see where you're going with this.
It doesn't tell you how the ingredients are transformed. It doesn't tell you what specific health and safety rules the chef is following.
Right, right.
And most importantly, it doesn't tell you how the kitchen handles exceptions. If they run out of tomatoes, does the chef substitute ketchup? Do they just leave the tomatoes off? Or does the entire kitchen panic and stop cooking altogether?
I love that.
Yeah.
The menu is a promise, but the kitchen is the reality.
Exactly.
If you don't understand the behavior in the kitchen, having a beautifully laminated, standardized menu doesn't solve the chaos behind those doors. You're just masking it.
Masking it perfectly.
And the source actually calls these thin veneers over opaque systems. So if I'm reading this right, layering an API on top of a legacy system without actually understanding the underlying behavior can actually increase the integration tax.
Drastically.
Really?
Because when you create an API, you make it incredibly easy for other internal teams or external partners to connect to that system. Friction drops to zero.
Well, that sounds like a good thing.
It is, until you realize what they're connecting to. Suddenly, instead of just two older systems talking to each other, you have dozens of new consumers relying on that API.
Oh, boy.
But if that API is just a thin veneer over poorly understood, leaky legacy logic, you've just multiplied your integration points.
You've just given everyone access to the chaos.
Yes. You have more teams depending on undocumented kitchen behaviors that no one fully understands. You aren't eliminating the complexity. You're just trading one form of integration complexity for another and spreading it much faster.
Here's where it gets really interesting. We've established that APIs aren't a magic shield and that this web of messy connections is growing non-linearly. We have a rapidly expanding network of teams, all depending on hidden behaviors.
A recipe for disaster.
Exactly. So what happens when this complex web is left unchecked? The source uses this terrifying phrase, the blast radius.
Yeah, the blast radius is the compounding fallout of all this unknown complexity.
Compounding fallout.
As integrations multiply through those thin APIs, change impact analysis slows to a complete crawl. Let's say a developer wants to update one simple field in a database. Maybe expanding a zip code field from 5 digits to 9 digits.
Seems simple enough.
In a healthy system, that takes an hour. But in this environment, they have no idea how many downstream systems rely on that exact field via undocumented integrations.
Because there's no map.
Right. Will changing that zip code format crash the payroll system? Will it trigger an automated fraud alert? No one knows.
So the developers get terrified. The text says this forces teams into a cycle of defensive engineering. And honestly, that sounds exhausting for the employees involved.
It's incredibly draining.
Instead of building cool new features that drive revenue, they're forced to add endless paranoid testing cycles. They demand more approvals, set up endless coordination meetings, and wrap every minor update in miles of red tape, all out of sheer fear that they're going to trigger the blast radius.
Yeah. And you can't blame them.
No. But a purely technical problem suddenly morphs into this massive organizational and cultural bottleneck.
And the financial cost of that defensive posture is staggering.
I bet.
The text points out that the incremental operational expenditure, the OPEX, for support, monitoring, and incident response persists and compounds year after year.
It just keeps growing.
Eventually, the sheer cost just to maintain these brittle connections and run these endless testing cycles rivals or even exceeds the original capital cost of developing the system in the first place.
Are you kidding?
No. You are basically paying for the system twice, just in maintenance.
And it's not just a budget issue either. There's a whole compliance nightmare hiding in here.
Oh, absolutely.
For anyone listening who works in a highly regulated industry like finance, healthcare, or government contracting, you know that regulators do not care about your technical debt.
They do not care at all.
They don't care that your blueprints burned in a fire. When an auditor walks in, they demand to know exactly how a piece of sensitive customer data transforms as it moves through your company.
If we connect this to the bigger picture, This is a massive enterprise resilience liability.
Right.
When a regulator asks, how is this specific piece of European citizen data validated across your system boundaries, and your integrations are opaque, leaky workarounds, you can't give them a straight answer.
Because you don't know.
Exactly. Answering requires a team of engineers to manually reverse engineer 15 years of point-to-point connections just to map the data flow.
That's crazy.
It turns every opaque integration into an automatic audit finding. And worse, when the things actually break, when there's a severe data breach or a massive outage root cause analysis becomes pure speculation.
Because nobody knows what triggered what.
Right. Incidents cascade across systems, taking down parts of the business you didn't even know were connected, while executives wait hours or days for answers.
It's the historic downtown analogy again. You break the 1920s water main, and suddenly the traffic lights stop working 3 blocks away. And nobody knows why because the systems are so locked in place.
Exactly.
The blast radius of any change feels entirely unmanageable. It paralyzes the entire enterprise.
Which perfectly explains why massive enterprises become so reluctant to modernize or replace their core systems. Everyone knows the mainframe's strategic value is declining.
Right, everyone wants to upgrade.
Everyone knows it needs to go. But the sheer terror of the blast radius keeps them locked in place. They are paralyzed by their own integrations.
Okay, we have painted a very vivid, somewhat terrifying picture of tangled, risky, exploding systems.
I really have.
We need a way out. If you are listening to this on your commute and sweating about your own company's IT infrastructure, take a breath. The source material does provide a practical, actionable solution.
Thank goodness.
It's something Codora calls system intelligence.
The central realization behind system intelligence is really pragmatic. Enterprises cannot simply pause their operations to rewrite all their old code.
No, of course not.
You can't shut down a global logistics firm for a year to untangle the spaghetti. The fix has to be incremental, and it has to happen alongside ongoing daily delivery.
So what does this all mean? If we can't pause the business and we can't rip out the old code, how do we even begin to untangle it? Are we essentially just turning on the lights so we can finally see how the wires are connected?
Turning on the lights is the perfect way to frame it, because system intelligence is fundamentally about cartography.
Map making.
Right. It addresses the root cause of the integration tax, which is the lack of a shared, durable map. The goal is to make execution paths, data flows, and dependencies completely explicit.
You replace the guesswork.
You replace the guesswork and the fear with hard, verifiable evidence. The process begins with visibility.
Step 1, visibility. Got it.
Before you change anything, you use automated tooling to trace the data flows. You find the brittle integrations. You map out which systems consume which data, how transformations actually occur in the wild, and exactly where the exceptions are handled.
So you are rebuilding the lost blueprints by analyzing the live system.
Precisely.
And once you have that map, you don't just blindly start replacing every pipe. The text talks about prioritizing the effort.
That's step 2, prioritization.
You target the high-risk hotspots. You look at the map and say, okay, this specific cluster of undocumented connections is driving 50% of our compliance exposure.
Or this one middleware logic leak is causing all our checkout failures.
Right. You fix the pipe that's leaking over the main electrical panel first before you worry about the pipe leaking into the empty basement. It gives you outsized returns for your effort without having to boil the ocean.
Exactly. You stabilize the most dangerous areas first. But the real cultural shift happens in step 3, which is how you handle new builds moving forward.
Shifting new builds. Okay.
As teams build new integrations, like that Apple Pay connection, they don't just add to the debt. They capture behavioral understanding as part of the delivery process.
Ah, so they document it properly.
Yes. They document not just the API interface, but the behavior. They document the kitchen rules. Each new integration actually strengthens the intelligence layer.
This makes so much sense. It creates a shared, durable understanding that outlives any single developer.
That's the key.
The architects, the mobile developers, the compliance teams, the security auditors, they finally all speak a common language. They are all looking at the exact same map of the city.
And that shared map is the real cure. The goal is absolutely not to eliminate integrations. Integrations are the lifeblood of a modern business.
We need them.
The goal is to turn integration from a hidden, compounding tax into a controlled, predictable investment. By maintaining continuous system intelligence, the understanding evolves naturally as the integrations evolve.
That prevents the debt from piling back up.
Right. It eliminates the need for paranoid defensive engineering, and it brings change velocity back to the enterprise.
This has been such a massive paradigm shift. To summarize the mission we set out on today, the real threat to aging enterprise systems isn't the old legacy code itself.
Not at all.
It's the invisible compounding web of opaque connections holding it all together. The integration tax, it drains your budgets, it causes massive compliance nightmares, and it slowly kills your company's agility.
It really does.
So the next time a major initiative at your company stalls out or goes massively over budget, don't just look at the core applications, look at the connections, look at the empty spaces between the systems.
That is where the real complexity lives. And acknowledging that that space requires its own rigorous intelligence and mapping is the very first step toward regaining control of your architecture.
Absolutely. Now, before we wrap up, I want to leave you with a final thought to ponder.
Always the best part.
We've spent this entire deep dive talking about how painfully difficult it is for human teams to manage this integration tax over decades of company growth. But think about where technology is heading right this second.
Oh, yeah?
What happens as companies start using AI to write code? Will AI-generated integrations be spun up so incredibly fast with so little human oversight that this invisible tax comes out in days rather than decades?
That's a terrifying thought.
Or, and this is the flip side, will AI be the very tool that perfectly maps and documents all these hidden behaviors, giving us instant, flawless system intelligence across the whole enterprise?
That might be the multi-million-dollar question for the next era of enterprise tech. AI could be the ultimate accelerant of technical debt, or it could be the ultimate cure.
It really is the ultimate double-edged sword. Keep an eye on how that dynamic unfolds in your own industry, because whether you are dealing with a human-built legacy system from 1995 or a hyper-fast AI-generated web from last week, you still have to know exactly where the pipes are buried before you start digging up the street.
Otherwise, you're just waiting to hit that high-pressure water main.
Thanks for joining us on this deep dive.